Now we reach practice 3C. I will solve some of the questions. I hope you will understand better. Once the create in sample problem 3C is in motion, in the sample problem 3C, mass of the object was 24 kilogram, by the way. A horizontal force 53 Newton keeps the crate moving with the constant velocity. Constant velocity means F net acting on object must be 0. Find the mu k, the coefficient of the kinetic friction between the crate and the floor. So that means we have got an object here. That object exerts a force 53 Newton in this direction, and there is a force in opposite direction, which is the kinetic friction force, and the downward we have Fg equal 24 m times g, that is 24 times 10, which is 240 Newton, and in the upward will be Fn normal force also will be 240 Newton in this question. And if the question says constant velocity, so this is moving on the plane, so external force must be equal friction force. So that means F net is 0. So F must be equal Fk. So Fk equal 53 Newton. And the question says find the kinetic friction coefficient. That means mu k equal Fk over Fn. So mu k will be, Fk is 53, Fn as we calculate 240, 53 over 240 will be 0.22, and there is no unit for the kinetic friction coefficient. Thanks for listening. Hello, welcome everyone. In this question it says 25 kilogram chair initially at rest on a horizontal floor requires 165 Newton horizontal force to set, this is the important sentence, to set in motion. Once chair in motion, 127 Newton horizontal force keep moving with the constant velocity. So we have 2 points here. To set it in motion, it means it is the maximum static friction force. So in this case, Fs will be 165 Newton. And it says 127 Newton horizontal force keep moving with the constant velocity. Constant velocity means F net is 0. So if the F net 0, force of kinetic friction must be same as the external force. So Fk must be 127 Newton in this question. And at the A, it says find the coefficient of static friction, and B, it says find the coefficient of kinetic friction. And if we draw our object, that is 25 kilogram, Fg of the object will be 250 Newton. So Fn will be 250 Newton again. For the A, it's asking static friction coefficient, that means mu s equal Fs over Fn. Fs is 165 Newton over Fn is 250. 165 over 250 is 0.66. And for the B, it's asking mu k, it is Fk over Fn. Fk is 127 Newton over Fn is 250 Newton, and that will be equal 0.5, and there is no unit for it. Thanks for listening. The question says a museum curator moves artifacts into place on many different display surfaces. Use the values in this table, then find the Fs and the Fk for the ball-loving situation. Steel on the steel, I have to use this constant. Aluminium on steel, I have to use this constant. Wood on wood, I have to use this constant. Glass on glass, we have those constants. And at the A, it says aluminium on a steel. So I have to use this constant for the A. And we have an object 145 kilogram. That means Fg of the object 1450. Fn of the object 1450. And then if we calculate Fs, it is mu s times Fn. So mu s for the A, this is the static friction, this is the kinetic friction coefficients, by the way. And for the A, it is 0.61 times 1450, and it will be equal 885 Newton. And the Fk will be mu k times Fn. So mu k is given 0.47 times 1450. So Fk will be 682 Newton. And this is stands for the A. And now I'm gonna calculate the B. And at the B, pulling 15 kilograms steel on a steel. So this stands for the B. So we have different Fn here. Fn in this question, it is 15 kilograms. That means 150 Newton, we can say directly. So Fs equal mu s times Fn. For the B, mu s is 0.74 times 150. 0.74 times 150, 111 Newton. And the Fk will be mu k times Fn again. And mu k for the steel on steel, 0.57, 0.57 times 150, 0.57 times 150 equals 86 Newton. And for the C, it says 250 kilogram wood on wood, wood on wood. So this is the C. So here our Fn will be 2500 Newton. Fs equal mu s times Fn. So mu s for the C, 0.4 times 2500. 0.4 times 2500 is the 1000 Newton. Fk is mu k times Fn. So 0.2 times 2500, it will be 500 Newton. And the last choice, which is D, we have 0.55 kilogram glass. That means Fn will be 5.5 Newton. And the Fs will be, this is glass on glass, Fs will be 0.9 times 5.5, that is 5 Newton. Fk will be 0.4 times 5.5, so result will be 2.2 Newton. Thanks for listening. Now we reach practice. I will solve some of the questions. Hello, welcome everyone. In this question, it says a student pulls on a rope attached to a box of books and moves the box down the hall. The student pulls with the force of 185 Newton, an angle 25 degrees above the horizontal. The box has mass 35 kilogram and mu k between the box and the floor 0.27. Find the acceleration of the box. So if we draw the box, we have a force which is external force that's equal 185 Newton, and it has an angle 25 degree with the horizontal line. we can say. And it is mass 35 kilograms, so Fg 35 times 10, it means 350 Newton. And the box is moving, and it's moving to the right direction, and the question says find the acceleration. So in the opposite direction there will be friction force of the kinetic. And in this type of question, firstly we have to draw the free body diagram. And what force more we have? We have normal force, which is upward. And then we have, as a second step, we have to separate the force into component Fx and the Fy. Fx is the F time 185 times cosine 25. Fy is the 185 times sine 25. So that Fy is 78 Newton, Fx is 168 Newton. And the third step, we have to find Fn. How can we find the Fn? Downward we have 350, upward we have 78, and the Fn. Up force and the down force must be equal each other. So Fn plus 78 must be equal 350. So that Fn will be 272 Newton, we can say. Then next step, we have to find the acceleration. So acceleration equal F net over mass. So the mass of the object is given. We know it. If we calculate the net force, that means we already solved the question. And the F net in this question, the object moving in the horizontal line to the direction of the Fx. So net force here will be Fx minus Fk. And Fx we calculated 168. So we have to calculate Fk. And Fk equal mu k times Fn. Mu k is given in the question 0.27 times Fn is the 272, we can say, and the result will be 73.4 Newton. And to calculate the acceleration, again I will write the formula. F net equal F net over mass. F net equal Fx minus Fk over mass. So acceleration will be Fx is the 168 minus Fk is the 73.4 over mass is 35 kilogram. And acceleration gonna be 2.7 meter per second square. Thanks for listening. Hello, welcome everyone. In this question, it says the student in item 1, that means at the first question, moves the box up a ramp inclined 12 degree. And the previous question, mass of the object is 35 kilogram first of all. And with the horizontal, so there is a ramp and it says an angle 12 degree. If the box starts from rest at the bottom of the ramp and is pulled at an angle of 25 degree with respect to incline with the same 185 Newton force, what is the acceleration up the ramp? Assume that mu k equal 0.27. So this question, it is not on the horizontal line, it's on an inclined plane. So if we draw our object and inclined plane angle is 12 degree and the force will be like this, acting on like this, with the 185 Newton, and it has angle 25 degree, we can say. And system is moving in this direction of motion, we can say, of motion. And in this question, first of all, we have to draw free body diagram. And firstly, we have to draw Fg, that means weight of the object. It is 35 kilogram, so it will be 350 Newton if we take the G 10. And in the opposite direction of the motion, there will be Fk, kinetic friction, and there will be Fn here, which is perpendicular to the surface. And the next step in this type of question, we have to find component of the forces. F has component Fx and the Fy. Fg has component Fgy and the Fgx, we can say. And the third step, we have to calculate the component. Fx equal 185 times cosine 25, that's equal 168 Newton. Fy is 185 times sine 25, so that's equal 73 Newton. And we have to calculate also Fgy and Fgx. So this angle equal this angle, so this is 12 also, we can say. So Fgy will be 350 times cosine 12, so it will be 342, and Fgx will be 350 times sine 12, so it will be 78 Newton. Next step, we have to calculate the normal force. If we talk about the normal force, in this direction we have Fy, which is 73 Newton, and we have Fn, and in the downward we have Fgy, and that Fgy equal 342 Newton. And this direction of the force and this direction of the force must be equal each other. So Fn will be, or Fn plus 73 must be equal 342. So Fn will be 342 minus 73. So Fn will be 264 Newton. And then we have to do calculation for acceleration, and acceleration equal F net over mass. Mass is given, so we have to calculate F net. And what is the F net here? The system is moving in this direction, as I told you before. So Fx minus, what's the forces in opposite direction? Fk and Fgx. So Fx we calculated, Fgx we calculated, so here we have to calculate Fk. And how can we calculate Fk? It is equal mu k times Fn. And mu k in this question is given in the question 0.27, and as we calculate, Fn is the 264. So Fk gonna be 71 Newton. So all the givens I will substitute in the formula. So acceleration equal F net over mass, and F net equal Fx minus Fk minus Fgx over mass. And fx is the 168 minus fk is the 71 minus fgx is the 73 over mass is the 35 kilogram. So acceleration gonna be 0.7 meter per second squared. Thanks for listening. Hello, welcome everyone. In this question it says 75 kilogram box slides down 25-degree ramp with an acceleration of 3.6 meter per second square. At the A it says find the mu k between the box and the ramp. At the B it says what acceleration would a 175 kilogram box have on this ramp. Let's solve the A first. And I will draw the figure first to make it a bit easier. So angle of the ramp is the 25 degree. And let's say the box is here and box mass is the 75 kilogram. So Fg of the box will be 75 times 10, 750 Newton. And in this type of question, first of all, we have to draw free body diagram. And in the system, there is no any external force. We have component of the Fg, Fgy, and the Fgx. The object moving with the force of the Fgx, and in the opposite direction, there will be Fk, and there will be normal force on the system, which is perpendicular to the surface of the motion. And here, acceleration is given, and the mass is given, so I can calculate the net force. Net force equal mass times acceleration. Mass is 75, and acceleration it is 3.6, so it will be 270 Newton. And then another step here, I have to calculate the component of the vectors. The angle here, which is equal this angle, this one, which is 25. So Fgy equal 750 times cosine 25, and Fgx will be 750 times sine 25. Fgy will be 680 Newton. Fgx will be 317 Newton. And here Fgy equal Fn, directly we can say. So value of the Fn will be 680 Newton, directly we can say. And the question says find the mu k. We can calculate the mu k from the formula of the Fnet. And the Fnet here in this question is equal Fgx, because system is moving, sliding in this direction. So Fgx minus Fk, friction force. So we calculate the Fgx, we calculate the Fnet, and I do calculation for the Fk, then I will find the mu k. And I will continue here. Fnet equal 270 Newton. Fgx is equal 317 Newton minus Fk. Fk is mu k times Fn. Mu k times Fn. And the Fn is 608. So we send this one to here, this one to here. Mu k times 680 equal 317 minus 270. If we divided both sides 680, we will obtain mu k. And the mu k equal 47 over 680. So it will be 0.07. And At the B it says, what acceleration would 175 kilogram box have on this ramp? It says, so we have to calculate fgx and the fgy again. So fgy will be now 1750 because we have a new weight, that means we have new mass, times cosine 25, and the fgx 1750 times sine 25. So fgy will be 1586 Newton, we can say, and fgx will be 740 Newton, and fn will be fgy here again, because there is only one force in that direction, 1586 Newton. So acceleration will be F net over mass, and F net equal Fgx minus Fk over mass. So Fgx is 740 as we calculate, minus Fk is mu k times Fn, so mu k is 0.07 as we calculated the A, times 1586 over mass. Mass will be now 175 kilogram. So acceleration gonna be 3.6 meter per second squared. Thanks for listening. Hello, welcome everyone. In this question it say a box of books weighing 325 Newton moves at a constant velocity. Constant velocity means net force acting object is 0 across the floor. When the box is pushed with the force 425 Newton exerted downward at an angle of 35.2 degree below the horizontal. Find mu k between the box and the floor. So question says find the mu k. That means what's the mu k? And firstly, let's draw the box. Then we have to draw the free body diagram. The force is like this, equal 425 Newton, and the degree below the horizontal 35.2 degree, and Fg of the box is given 325 Newton directly. System was moving in this direction of motion. So in opposite direction there will be kinetic friction force, and there will be normal force also here. And first step, we have to find component of the forces Fx and the Fy. Fx here equal 425 times cosine 35.2, and that's equal 347 Newton, and the Fy equal 425 times sine 35.2, and that will be equal 245 Newton. And here upward force must be equal downward force. That means Fn will be equal 325. It means Fg plus Fy, 325 plus Fy is 245. So Fn gonna be 570 Newton. And the question says find the mu k. So we can calculate from the Fnet formula. Fnet due to information of the question, which is constant velocity, it is 0. And the system is moving in this direction, so F net will be equal Fx minus Fk. So that's equal 0 equal Fx minus Fk. So in this question, Fx equal Fk. And we have calculated Fx, which is 347, equal Fk. Fk formula mu k times Fn, and the Fn is 570 Newton, we can say. If we divide both sides, 570, mu k gonna be 0.6. That's all. There is no unit for the friction coefficient. Thanks for listening.